Welcome to a new series, By a Few Degrees, where direction, not chance, writes history. Only on your dose of Wowness.
9 episodes ago, we started with an angle nobody chose, a 60-degree impact that ended the age of dinosaurs. Since then, a wind, a helm order, a docking turn, a re-entry corridor threaded almost blind. Every single one decided by something completely outside human control. Today, for the first time in this entire arc, that changes. In September 2022, a spacecraft slammed into an asteroid on purpose, and for the first time in history, humanity chose an angle instead of inheriting one. This is Day 10, the finale of By a Few Degrees. If you've been with us since Chicxulub, thank you for sticking with all 10. Subscribe if you haven't yet, because this channel isn't done finding stories like this one. Across the 9 episodes that led us here, the geometry was always dictated by external forces, from the wind that scattered the Spanish Armada to the chaotic gravitational dynamics that shaped Shoemaker-Levy 9's path toward Jupiter. That pattern shifted in November 2021, when NASA launched the mission to actively intervene in those same orbital mechanics. NASA designed this mission as a controlled trial to prove that the physics governing every unchosen angle we've talked about can be steered on purpose. This image shows the target, a 780-meter asteroid named Didymos, and its small orbiting moon, Dimorphos, which measures roughly 160 meters across. Choosing a binary system was strategic. By altering the moon's path around the larger asteroid, scientists could precisely measure the results from Earth-based telescopes without requiring a second spacecraft to stay behind and observe. Current tracking data confirmed that neither rock posed a threat to Earth before the launch, and that status remains unchanged today. This harmless, distant proxy provided the necessary environment to test planetary defense theories without real-world stakes riding on the outcome. The physical mismatch between the two objects was extreme. A 570-kilogram spacecraft hurtling toward a solid 160-meter-wide rock. The kinetic-impactor technique relies on the basic physics of momentum. The goal is to alter a massive object's orbit by striking it with a smaller mass at roughly 14,000 miles per hour. On September 26, 2022, the DART spacecraft's final images showed the rocky surface of Dimorphos filling the frame until the signal cut out at the moment of impact. If this series has changed how you think about the word angle, tell us in the comments which episode stuck with you most. We read all of them, and it genuinely shapes what comes next. The spacecraft's total destruction served as the final evidence of high-precision human engineering. Follow-up observations confirmed a historic result. Dimorphos's orbital period around Didymos shortened by approximately 32 minutes. This shift exceeded NASA's requirements because the collision transferred the spacecraft's momentum while simultaneously creating a recoil effect from the debris ejected during the strike. We should be precise about the scope of this achievement. DART proved the concept under long-planned, controlled conditions on a very small body. A genuine threat could be significantly larger, discovered with less notice, and possess a structural composition that reacts differently to a kinetic impact. DART transformed planetary defense from a whiteboard equation into a verified mechanical reality, though it remains a foundation rather than a finished solution. That foundation will be relevant in April 2029, when the 340-meter-wide asteroid Apophis makes its close approach to Earth. While Apophis caused early concern after its discovery, current tracking data effectively rules out any collision risk for this pass. The asteroid will pass within 20,000 miles of Earth's surface, closer than geostationary communication satellites, and visible to the naked eye. This provides a unique window for researchers to study how Earth's gravity affects an asteroid's structure and spin in real time. Because of the data gathered by DART, this close pass serves as a live testing environment for our future survival, rather than a source of panic. 66 million years separate the geological evidence of the Yucatan impact from a research opportunity humanity is now actively preparing to study on purpose. 66 million years ago, an angle nobody chose ended one world. In 2022, humanity chose one of its own for the first time. In 2029, we'll get our next real look at what that means when Apophis passes closer to Earth than our own satellites. That closes out By a Few Degrees. 10 stories, 1 rule. The angle decides everything. We're already working on what comes next for this channel, and when it's ready, you'll be the first to know. Thank you for watching all 10 of these with us. For the first time, we have moved from merely inheriting the geometry of the cosmos to actively drawing our own lines.